Hello everybody, Sir Leon here and welcome back to another mathematics video. And in this video, we'll be looking at a beautiful topic, relations and functions. And at the end of this video, you should be able to do three things. One, you should be able to correctly identify the types of relations. Two, you should be able to correctly state the order pairs in a relation. And three, you should be able to identify functions. So let's head straight into the video. First thing first, what is a relation? Now it says a relation is a set of ordered pairs, and we know pair we're talking about two, a set of ordered pairs that obeys a particular rule. That is what a relation is. To speak more to this, let's look at a diagram. Let's say we have an arrow diagram, and in this arrow diagram, this is what an arrow diagram looks like. In this arrow diagram, we have two ovals. And let's say in one part of the arrow diagram, on this side, let's call this X and let's call this side Y. In the X part, we have the numbers 1, 2, and 5. And on the other side, we have the numbers 6, 7, and 10. Now, in order to link X with Y, they must follow a particular rule for us to consider them a relation. Now, this rule would simply mean what is there to link X and Y. How can we link X and Y? So for this example, in mathematics, let's say we have a rule to link these two. Let's say X plus 5. And that would be the rule that we will follow to link what is in X to what is in Y, to pair off. So in the first value in X, we have 1, and we can see the rule is X plus 5. So in this case, it will be, instead of X, it will be 1 plus 5 will give you 6. So we'll take an arrow and draw from 1, and we go straight to 6. And then we'll take, for the second one, we have 2. So this will be 2 plus 5. So we take an arrow and we draw from 2, and we go straight to 7. Because 2 plus 5 will give you 7. And then for the last one, 5 plus 5 would give me 10. So I take an arrow and draw from 5, and I go straight to 10. And this is what a relation is. We have an arrow diagram, and it's a rule to link one side to the other side. And if we said that it's a set of ordered pairs, so let's list the pairs that we can find from this arrow diagram that follows this particular rule, which was X plus 5. So for the first pair, we have 1, and then we see that is paired with 6. And then for the second pair, we have 2, and we see that is paired with 7. And then for the third one, we have 5, and that is paired with 10. And this is what a relation is, a set of ordered pairs that obeys a particular rule. So we need to know some concepts as it relates to relation. And this is where we now look at the domain, the codomain, and the range. We must be able to identify what is the codomain in this relation, what is the domain, and what would be the range. So let's draw another arrow diagram to explain this concept. Let's say in this arrow diagram, we have 5, 6, 7, and 8. And this part of the arrow diagram, we have 1, 2, 3, 4, and 10. So we'll map 5 on to 1. Then we map 6 on to 3. Then we map 7 on to 3. And then we map 8 on to 4. And this would be X, and this would be Y. So for the domain in this arrow diagram, it will be every element that will be mapped onto something that is coming from something in the arrow diagram. In this case, it will be all of the elements in X. We consider those the domain. So for this here, the domain would be 5, 6, 7, and 8. And the codomain in this example would be everything in Y. regardless of if it's something is mapped onto it or not, as long as it's in Y, that would be the codomain. 1, 2, 3, 4, and 10. And the range in this example, the range would be everything that is being mapped onto. So everything that is being mapped onto something, for example, we see the 1 is being mapped onto, the 3 is being mapped onto, and the 4 is being mapped onto. We consider those the range. So the codomain is everything inside, and the range would be everything that is being mapped onto. So in this case, the range would be 1, because that is being mapped onto, 3, because that is being mapped onto, and 4. And that is how we identify what is the domain, the codomain, and the range. Domain, everything that is coming from the codomain, everything in the other part of the arrow diagram, and the range would be everything that is being mapped onto. So let's move on to the types of relations. So we have basically 4 main types of relations. And the main one that you will come across, the easiest one to identify, would be the one-to-one relation, which would be this one. So in the one-to-one relation, each element in the domain is mapped onto one and only one element in the codomain. So in this case, we have 4 is mapped onto 2, 9 is mapped onto 3, 16 is mapped onto 4, 25 is mapped onto 5. And as you can see, one element in the domain is mapped onto only one element in the codomain. And next we have the one-to-many relation. In this case, one element in the domain is mapped onto more than one element in the codomain. So in this case, we have B, and we can see there are many arrows coming from B. So B is mapped onto many. So that is why it's called a one-to-many. So we see B is mapped onto E, B is mapped onto F, B is mapped onto H. So it's a one going to many. And in the next part, we have the many to one. Now in this case, we have many going to one. So at more than one elements in the domain is mapped onto the same element in the codomain. More than one element. So in this case, we have 3, 2, and -2 all being mapped onto 4. So this is called a many to one because we have many going to one. Then we have the many to many relation. In this here, we have a combination of the one to many and the many to one. So we have one going to many, and then also in the same arrow diagram, we have many going to one. So in this case, we have B being mapped onto E and H, and also we have B and C being mapped onto E. So we have a combination of one to many and many to one. And that is how we identify different types of relations. So let's look at the next exercise now. So this exercise is, given X is mapped onto 3X plus 1, complete the arrow diagram. So we have all of the elements in the domain, in this case, which is X, and it's being mapped onto the codomain using the rule 3x plus 1. So you have to take each element in the domain and plug it in this rule, and we'll receive an element in the codomain. So for the first one, we have 0. So the rule is 3x plus 1. So this will be 3 multiplied by 0 plus 1. So 3 times 0 is 0, plus 1 would be 3, 0 is 0, plus 1 would be 1. So 0 will be mapped onto 1. Then we have the next element in the domain, which is 1. This is 3 multiplied by 1 plus 1 is equal to 3 1's 3 plus 1 would be 4. So the element here would be 4 in the codomain. The next one, we have 2. This will be 3 multiplied by 2 plus 1 would be equal to 3 2 is 6. 6 plus 1 would be 7. So the 2 will be mapped onto 7. The next one, we have 3. This will be 3 multiplied by 3 plus 1 would be 3 3 is 9. 9 plus 1 would be 10. So 3 will be mapped onto 10. Then we have 4. This will be 3 multiplied by 4 plus 1 would be 3 4 is 12 plus 1 would be 13. So 4 is mapped onto 13. And that is how we complete the arrow diagram. And if we are asked to list all of the elements in the codomain, those elements would be 1, 4, 7, 10, 13. And if you're asked to list the ordered pairs would be 0 and 1, that would be a pair, 1 and 4, 2 and 7, 3 and 10. And then we'll have the last pair, which will be 4 and 13. All of these things, they follow a rule for them to be paired with each other. So let's look at another question. This question says, draw the relation diagram for the relation defined as follows. And we have the relation. X is mapped onto 2x plus 1. And we have the domain, which should be -3, -2, -1, 0, 1, 3. And then they ask us to state the type of relation in the diagram obtained. So let's go. Let's draw the domain. So the domain would be -3, -2, -1, 0, 1, 3. I can call this X. And this will be mapped onto, we have the rule, X, 2x plus 1. So let's call this Y. So the rule is 2x plus 1. So the first x, we have 3. So this would be 2 times -3 plus 1. And 2 times -3 would give you a -6 plus 1 would give you a -5. So -3 is mapped onto -5. So we can draw that arrow diagram. And then we have -2. This would be 2 times -2 plus 1 is equal to 2 times -2 is -4. So -4 plus 1 would be -3. So -2 will be mapped onto -3. Then we have -1. This will be 2 multiplied by -1 plus 1 is equal to 2 times -1 would be -2. So -2 plus 1 would be a -1. So -1 will be mapped onto -1. Then we have 0. So 2 times 0 plus 1. 2 times 0 is 0. 0 plus 1 would be 1. So 0 will be mapped onto 1. And then we have 1. 2 times 1 plus 1 would be 2 ones 2. 2 plus 1 would be 3. So 1 will be mapped onto 3. Then the last one, we have 3. This will be 2 multiplied by 3 plus 1 will be equal to 2, 3, 6. 6 plus 1 would be 7. So this 3 is mapped onto 7. So we have the relation. So we see each element in the domain is mapped onto one and only one element in the codomain. So for this type of relation, this will be a one-to-one relation because each element in the domain is mapped onto one and only one element in the codomain. And with that, let's move on to another aspect of relation, which would be functions. Now, the definition of functions is a function is defined as a relation, so a function is a relation in which each element in the domain is mapped onto one and only one element in the range. No element in the domain can remain unmapped. No element in the domain can remain unmapped. So each element in the domain must be mapped onto something. We cannot have an element without that element being mapped to something. So what that is saying, if we have an arrow diagram like this, let's say 1, 2, 3, and you have 5, 6, and we have 1 going to 5, 2 going to 6, and 3 not going anywhere, this cannot be a function because the 3 is unmapped. So this is not a function. So in the exam, they will ask you to identify functions from diagrams and so on. And there is an easy way to identify whether a diagram is a function, whether a line is a function, whether a function is a function. And most times they will give you this in the form of a diagram, and they will tell you identify, state whether it's a function or not. Or they may give you a set of diagrams and say state which one is a function or which one is not a function. So in the first one, we have this line being drawn here. And how can we identify whether this line is a function? So there's a test that we do that is called the vertical line test. Now for the vertical line test, we draw up vertical lines through the function. Now as long as we draw up vertical lines through the function and the vertical lines pass through one and only one part in the function, or one and only one part in the graph in this case, because we don't know if it's a function. So if it passes through one and only one point in the graph, then we can consider that graph to be a function. For example, we have all these red lines passing through this graph. And as we can see, the red lines only touch one part alone on the graph. So we can consider this graph to be a function. Let's look at another one. Let's look at this graph. So in this case, we have a parabola. But it's not an ordinary parabola. It's open across the x-axis. So let's see if this graph is a function. So as you can see, based on the vertical lines, we have this red line passing through this point and this point. So it passes through 2 points on the graph. So as long as one vertical line passes through more than 1 point on the graph, then it is not a function. So we don't need to test anymore, but as you can see, if we test another part, we see it passes through here and here as well. So this diagram here is not a function. So as long as we do the vertical line test, we draw up lines throughout the graph, and if the vertical lines passes through more than 1 point, then it is not a function. So you can take your ruler to do this test on any graph. So let's look at 2 more examples. So state whether the following relations represent a function. So we have A and we have B. So for A, if we do the vertical line test, we can see that the vertical lines will only pass through one and only 1 point on this graph. So we can say this for A, it is a function. And for B, if we do the vertical line test, we can see that it will pass through more than 1 point on the graph. So this one, B, is not a function. And that is as simple as that. That is how you identify functions in a graph. Just do the vertical line test, and as long as it passes through more than 1 point, it is not a function. And with that, it has brought us to the end of this video. And I trust that you now have a good understanding of relations, the types of relations, and also functions, and how to identify functions from graph. And with that, I look forward to seeing you in the next video. Take care.